We're going to continue our study on inverse matrices today. In particular, we're going to talk about how we can use them to solve systems of equations. So we've used matrices to solve systems of equations using the Gauss-Jordan method. But another way to use matrices to solve linear equations is to write the system as a matrix equation. So, for example, we have here A times X equals B. And we would say A is what we call the coefficient matrix. It's the one that holds all the coefficients. And X would be the matrix of the variables. So depending on how many variables you might have, this matrix could just be X and Y. It could be X, Y, Z. It could be more than that. And then lastly, we have the matrix of the constants, which is B. And that is whatever's on the right-hand side of your equations, the terms that do not involve X or Y. So how do we go about actually solving, well, what are we solving for? We're solving for the variables, X and Y, so the matrix of variables. We need to solve for our matrix X. So how do we do that? Well, in order to get X by itself, we would have to multiply both sides by the inverse. So if I multiply by the inverse of A on both sides, then the inverse of A times A is equal to the identity matrix. And since the identity matrix times anything is going to be that matrix, then this is just equal to X. So X is equal to A inverse times B. Now, remember from last time that not all matrices have inverses. So this method of solving a system of equations is only going to work if A inverse exists. So, to solve a system of equations A times X equals B, where A is the square matrix of coefficients, so A is always going to be a square matrix because your number of equations and number of variables should be the same. And A inverse does in fact exist, so the determinant is not equal to 0. X is the matrix of variables, and B is the matrix of constants. You want to first start off by finding A inverse. After you found A inverse, then you can multiply it by B, and that will give you your matrix of variables X. Let's take a look at an example. So here we have 2x minus 3y equals 4, and x plus 5y equals 2. I'm going to start off by writing out what each of my matrices are. So let's start off with A, the coefficient matrix. So that's going to be 2, negative 3, and then 1, 5. And then X is going to be my matrix of variables. I'm trying to solve for X and Y, so I'm going to write them down in that order, X and Y. And then B is your matrix of constants. So your constants are the ones that are on the right, so that's 4 and 2. So in other words, what we have here is A times X equals B would be like this. And you can double check and make sure that if you were to multiply these, you actually are working with the equations that you started off with, right? You would have to multiply 2 times X plus negative 3 times Y, and that should equal 4. And then if you did 1 times X and 5 times Y, add those together, that should equal 2. Now, we don't want to work with those equations. We want to actually use the inverse to help us solve this problem. So we're going to start off by finding the inverse of A. So I've written A up here in the corner. And to find A inverse, we're going to do 1 over the determinant, AD minus BC. And then we're going to have that matrix where you have A and D swapped, and B and C be the opposite. So that's 2 times 5 minus negative 3 times 1. That's the determinant in the denominator. We swap the 2 and the 5. And then we make the negative 3 and 1 the opposite. All right, simplifying this, it looks like we have 10 minus negative 3 in the denominator. 10 minus negative 3 is 13. So we have 1 over 13 times that matrix. And then we're going to go ahead and multiply that matrix by the scalar 1/13, and we'll end up with 5/13, 3/13, negative 1/13, and 2/13. Now that's finding the inverse of A. Remember, we're trying to find the matrix of variables. So what we're going to do is now we're going to have to multiply our matrix, the inverse of A, times the matrix B. Now remember, B is equal to 4, 2. So this is what we're multiplying. Now remember, when we multiply, we want to line these up. So we have A inverse on the left and B on top. And then we can multiply, and we know we're going to get a 2 by 1 matrix. So 5/13 times 4, that's 20/13. 3/13 times 2, that's 6/13. So 20/13 plus 6/13, that's 26/13, which is equal to 2. Do the same thing to get the next term. So we have negative 1/13 times 4 plus 2/13 times 2. So that's negative 4/13 plus 4/13, which is equal to 0. So our answer here is x equals 2 and y equals 0. Let's do another example for practice. So here we have negative 9x plus y equals negative 20, and then negative 3x plus y equals negative 14. Let's go ahead and start off by writing out our A, x, and B matrices. So A is negative 9 and 1, negative 3 and 1. X, we have x and y. And B, we have negative 20 and negative 14. Okay, so now, just so you have an idea of what we've done here, we're saying A times x is equal to B. You can double check that this does in fact give you those equations that we were given at the beginning. And now we're going to start off by finding A inverse. So here's A. So let's find A inverse, and then after we find A inverse, we'll multiply it by B. So this is 1 over negative 9 times 1 minus 1 times negative 3. Inside the matrix, we're going to swap the negative 9 and 1, make the 1 and the negative 3 the opposite, so it becomes negative 1 and positive 3. Let's go ahead and simplify that. So we have negative 9 minus negative 3 is equal to negative 6. So we have 1 over negative 6, or just simply negative 1/6. And then now we're multiplying a matrix by a scalar. So that's going to be negative 1/6, positive 1/6, negative 1/2, and 3/2. All right, we found A inverse. Now we need to solve for x by multiplying A inverse by B. So here's A inverse. I'm going to multiply it by B. So that's negative 1/6 times negative 20, so 20 over 6 plus negative 14 over 6, that's equal to 6 over 6, which is equal to 1. Okay, and then we have negative 1/2 times negative 20, and then 3/2 times negative 14, and that's equal to negative 11. So here we found x is equal to 1, and y is equal to negative 11. Okay, we have one last example. 2x plus 4y equals negative 10, and negative x minus 2y equals 5. Let's start off the same way. Let's write out our matrices for A, x, and B. So A is 2, 4, negative 1, negative 2. X is x and y. B, we have negative 10 and 5. And again, just to check that this is in fact what we want, we have 2x plus 4 times y is equal to negative 10. That's good. Negative 1 times x plus negative 2 times y is equal to 5. That looks like that second equation. All right, we start off by finding A inverse. So we have 1 over 2 times negative 2 minus negative 1 times 4. And then for the matrix, we're going to swap the 2 and the negative 2, and then the 4 and the negative 1 become the opposite. And now let's simplify this. So we have negative 4 minus negative 4. And then if we were to simplify that, that would be negative 4 plus 4, which is equal to 0. So A here does not have an inverse. That means that we cannot solve this using this method. So what do? Well, let's see what actually ends up happening. Why is it the case that we can't find the inverse? Well, let's go ahead and solve. Let's say we use elimination. So I'm going to multiply the second equation by 2. So now I have negative 2x minus 4y equals 10. And you can see here we end up with 0 equals 0. And in this case, that means we have an infinite number of solutions. Now, it's not always the case that we have an infinite number of solutions, but if you do have a determinant that's equal to 0, you could have infinite solutions. It could also be the case that you have no solution. So today we talked about how we can use matrix inverses in order to solve a system of linear equations. We only did linear equations with 2 equations and 2 variables because we've only talked about how you can find inverses of 2 by 2 matrices. So for all of these types of problems, you are always going to be first starting by writing out your A, X, and B matrices. And then you'll find A inverse. And once you found A inverse, then you would multiply that by B, and that will give you your matrix of variables X.